Welcome to Sundar's lecture. This is lecture number 27, and in the last class we have seen this topic, right? What is that? Star to delta conversion and vice versa, delta to star conversion. We have taken this resistor connections, this is star connection and this is delta connection, right? We have written the uh, resistor between, what is the resistance between RAB, RBC and RCA, and all those kind of things we have did, and we have found what is RA in terms of R1, R2, R3, RB in terms of R1, R2, R3 and RC in terms of R1, R2, R3. That is what here we have found, right? So if they have given you what is delta, then you can easily convert that into star, right? That is what we have seen in the 25th lecture. In the 26th lecture, we have used the same equations to find what is R1 in terms of RA, RB, RC, R2 in terms of RB, RA, RB, RC, and R3 in terms of RA, RB, RC. Which means if they have given you star connection, RA, RB, RC, then you can easily convert that into delta connection, right? That is what we have seen in the next lecture. See, R1 in terms of only RA, RB, RC. Like that, R2 and R3 we have found, right? So, in today's class, we will take an example problem, right? Numerical problem. So, this is the numerical problem given to us, and we need to find what is the effective resistance between R, E, F. Effective resistance between point E and F. You see this problem. See, outside this is a delta connection. This is delta connection, and inside this is star connection. You can easily see that. That is what we have drawn in the equation classes. See, this is delta connection outside, and this is the star connection. See, now we want to find what is REF, right? So you have to find what is the equivalent resistance in this circuit. That is our ultimate aim. Since this is 10 ohms resistor, that is very easy. That we can do by ourselves. But this one you need to find. It is not easy to find by our conventional techniques. So what we do now, let us convert this star to delta connection. Let us convert this star to delta connection. So we will get a double delta in this particular RABC circuit. So if you see, if you have let us find, then I will tell you um, uh, how this circuit looks very easy to find the equivalent resistance, right? So you see, I told you already, you have to take this point is A, this point is B, and this point is C. That is what we have. See here. This is A, this is B, this is C. That should be ABC. That is what we have. For that only we have derived the equation, and this has to be RA, this has to be RB, and this has to be RC. That should be very clearly taken, right? So you see RA, RB, RC, we need to write which is RA, RB and RC. See, here it is RA, this is RB, this is RC, right? So let us we write, I will write here in star connection. In star connection, you see this is RA, this is RB, and this is RC. I will write here. So for us, it is given as RA is equal to 1 ohms, comma, RB is equal to 5 ohms, and RC is equal to 7 ohms, right? So if you want to find a equivalent delta connection, right? I will draw this diagram anyhow. You see, like this, right? So this is 1 ohms, this is 5 ohms, and this will be 7 ohms. See, this is point A, this is point B, and this is point C, right? This is the star connection given, and this is nothing but RA, this is nothing but RB, and this is nothing but RC. Now we need to find the equivalent delta connection. What is the equivalent delta connection? See, this is resistor, one resistor, and we have this one, and we have here one resistor, and it is very clear that this is point A, this is point B, this is point C. There is no difference, but this is R1, this is R2, and this will be R3. See, that is what we have taken. That is why I am telling this one from the beginning, that you have to be very clear. in taking R1, R2, R3. See, this is what we have taken, R1, R2, R3. This is RA, RB, RC, right? Be very clear with that. That is the only thing. So what is the formula now? To find R1, see from here we will take, what is R1? R1 is equal to RARB plus RBRC plus RCRA and the divided by RB, right? So we will write here. So we will write R1 to find R1. What is R1? That is nothing but RARB plus RBRC plus RCRA whole divided by RB. So that is our formula, right? So if you substitute this RA, in this equation, what we will get? So R1 will be equal to RA into RB. That is 1 into 5. 1 into 5 will give you what? 5, right? RA, RB will give you 5 plus RB into RC. RB into RC. This will give you 5 into 5 into 7, that will be 35. So 5 plus 35 plus, and then RCRA 7 into 1. 7 into 1 will give you what? 7, right? 7 divided by, what is RB here? RB, which is nothing but it is 5 ohms, right? This will be 5 ohms. So if you further simplify this, maybe I will write it in, wait a minute. So if you further simplify this, what you will get? This is 42 plus 5, we will get 47 by 5. So R1 will be equal to 47 divided by 5, right? 47 divided by 5. So that is nothing but 9.4. Let it be very clear. That will be 9.4 ohms, right? So this is R1. Then we need to find what is R2, right? So R2. So what is the formula to find R2? See, R2, the numerator will be same, but the denominator is RC. Numerator will be same, that is this thing, but denominator is RC. That's all, right? So you see. So numerator, what is numerator? That is 47. That is why I have written this one very clearly. So this is 47. This is 47. That is same divided by, what is the denominator here? Denominator is RC. What is RC? RC is 7 ohms, right? That's all. So 42 divided by 6.71 ohms. Right? That is the final answer. Then we will go for R3. R3 will be equal to, see, numerator will be same, 47. There is no change in the numerator. But what is the denominator? What is the denominator? You see, this is RA. RA is the denominator, right? So RA will be the denominator. RA, what is RA here? RA is 1 ohms. RA is 1 ohms, right? So if you put 1 ohms here, then you will get 47 ohms. So now you see, we have got what is R1, what is R2, what is R3, right? So you can write it now here. Here you write it down. What is this value? R1, 9.4 ohms. And what is R2? R2, 6.71 ohms. And what is R3? R3 is 47 ohms, right? So this is how you need to convert the star connection to delta connection. Now you draw this delta connection to the circuit. That I will draw now. And you see, I have drawn this diagram. See, I have replaced this star connection with this delta connection, right? I have drawn here. See, anyhow, this is point A, this is point B, and this is point C, right? So I have written A, B, C. Now you see these two resistors. How these two resistors are connected? See, two ends were connected. So these two are connected in parallel, and these two are connected in parallel, and these two are connected in parallel, right? So we can simplify this. It is now simple. It is very easy. See, these two are connected in parallel, these two are connected in parallel, these two are connected in parallel. So if you simplify further this, so simplification, you know, right? Parallel resistor, how to how to find the equivalent resistor for parallel resistors. RP value, RP will be is equal to, I will write here anyhow. So RP will be is equal to, so uh, so this will be 4 ohms plus 9.4 ohms, and in the numerator 4 into 9.4, right? So which is nothing but R1 into R2 divided by R1 plus R2, right? If you simplify this one, you will get, so if you simplify this, this becomes, this RP becomes 4 point, sorry, this RP becomes, this RP becomes 2.80 ohms, right? So this is the first thing. Like that, this is the simplification of these two resistors, right? Let me make it as RP1, RP1. So instead of these two resistors, now we can write it as 2.80, and let us find what is RP2. If you want to find RP2, let RP2 be the this two parallel resistors. So that will give you, so in the denominator it has to be 6 plus 6.71, and in the numerator it will be 6 into 6.71, right? So if you simplify this, this RP2 will come as 3.17 ohms, right? So we have found what is the equivalent resistance at these 2 points, right? Which means parallel resistors. We have simplified, right? Then RP3, let RP3 be these two resistors, connections of these two resistors. So you will get, in the denominator we have to add, that is 47 plus 10, and in the numerator it will be 47 into 10, right? So at last, if you find what is RP3, RP3 will give you 2.86 ohms, right? So this is the three parallel resistors values. That means all the values can be now fit into this particular diagram. So I will draw that diagram now. So now you see, I have just replaced this diagram with the equivalent resistance we have found, right? So this is 2.8, 3.17, this is 2.86. Now you see, how will you find this one? What between these 2 points, these two resistors are connected in series, right? See, one end is connected, but other two ends are connected to a different point. So these two are connected in what? These two are connected in series, right? So series. So if you add this, RS will be equal to 2.80 plus 2.86, right? So what you will get? RS becomes what? 4.86 ohms. So see, this 4.86 ohms will be connected like this, parallel to this 3.17 ohms, right? So what we can do, RP will be equal to, already this is 4.86 ohms, already this will be 4.86 plus 3.17, and as well as 4.86 into 3.17, right? I am just directly writing the values. You can find it by yourself. Anyhow, I have done this with the same steps, right? So if you find this between point A and B, I am just going to find what is the resistors connected, right? So if you simplify, sorry, this value is 5.66, right? So this is actually 5.66 ohms, and here it has to be 5.66 ohms, and here it has to be 5.66 ohms. Just I have not added this one properly, right? 2.8 plus 2.86 will give you what? 5.66. So I have changed this. So you will get 2.03 ohms. 2.03 ohms, right? So between these two, A and B, we will get 2.03. And you see, I have just drawn this diagram. Now, how these two resistors are connected? These two are connected in series, right? So between R, E, F, you will get 10 plus 2.03. So the final value will be, REF will be is equal to 12.03 ohms, right? So this is the final value, right? So this is how you need to find the resistors between the two ends, right? Thank you. We will see in the next class.